So my name's Cam. I'm here today to talk to you about micro frontends. I'm a full-stack developer and a consultant, so I've worked with ThoughtWorks now as a consultant for about 5 years. I've worked all over the tech stack in that time, so I've done front-end work, back-end work, a bit of infrastructure as well. But yeah, probably the work that I'm most proudest of would be helping large organizations to do front-end development really well, and especially to help them scale it across multiple teams and deliver code into production really quickly and efficiently. Also, sorry, I don't look like my profile picture. I grew my hair out. So let's get the obvious comparison out of the way first, which is micro frontends. Well, what's that about? Is it just microservices? So yeah, microservices, that's a thing. There are obviously lots of advantages and disadvantages and trade-offs when it comes to microservices. The relevant similarity or comparison that we're making here is that it's all about taking something which is really huge and scary and monolithic and highly coupled and trying to separate it out into a bunch of small things that can be worked on independently, which are hopefully pretty simple and easy to work on, and that can be delivered by autonomous teams. I've certainly seen over the last few years there's been a lot of attention to back-end code and figuring out how to do that really well on the server. But for some reason, there seems to be a lot less attention being paid to front-end code and trying to figure out how to split up monolithic front-end. So I still see a lot of chaos, a lot of, there's 100 people all working on the same code base, and it doesn't tend to go very well. What we are seeing is user experience is obviously becoming more and more important. It's already hugely important, and it has to be a real differentiator for companies. And companies are realizing this and investing more into the user experience of their products. That tends to make the front-end code, but means we have more of it, and it usually becomes more complex as well in order to implement the kind of experiences that we want to deliver to our users. So our code is becoming more complex, and we're actually struggling to deal with a lot of that complexity. So we need better techniques, better architectures to try to deal with the complexity of front-end code. Let's jump into an example. So this is an application that I worked on back in 2015, 2016. It's a profit and loss report. For all the accounting fans in the room, this is just one of the reports that you might use if you're an accountant. And this is a totally self-contained application. It has its own code repository, it has its own set of dependencies, its own automated test suite, its own build pipeline, which takes it all the way to production. And if you knew an obscure URL, you could actually see it like this in production. In practice, though, what our users would see was this. So the P&L was actually a micro front end, and it was just one part of a broader product called MYOB Essentials. Is there anyone from MYOB in here? I know there's a few MYOBers, so cool. So you might be quite familiar with this application. This is the old brand, so apologies for using the old brand. The screenshot's a few years old. So Essentials at the time was a big monolith. It was pretty scary. People didn't really want to touch it. People didn't want to work on it. It was pretty difficult to add new features to it, or at least to do it quickly. And it was difficult to add new technology to it. So when the P&L needed some love, it used to not look as nice as this. It was decided that rather than try to extend the monolith that was already there, rather than try to rewrite the profit and loss report within the monolith, we thought, let's pull it out. Let's make it its own standalone application and then embed it within Essentials as a micro front-end. We weren't calling it micro front-ends at the time, but that's what it ended up being. So now we have a standalone application, which is nice and small compared to the rest of Essentials. It was quite small, quite simple, easy to work on. It was very highly cohesive and encapsulated. Everything that was in that code base was to do with nothing but the P&L. So as a team, we were highly autonomous and we were fast. We owned everything to do with our application, starting from ideation and thinking about what features we want, through to development, testing, deployment, and maintenance of that application. We also owned the entire tech stack, so we owned the front end, the back end, database, infrastructure, everything that we needed to get changes to this application into production. So this to me really captures what micro front-ends are all about, which is that it's an architectural style where independently deliverable front-end applications are composed into a greater whole. So now that we know what we're kind of aiming for and what some of the desirable attributes are, I'm just going to go through some of the problems that actually need to be solved in order to implement this. So at this point, I'm going to jump into a different example. So here's a hypothetical food delivery website called Feed Me, and we're going to build it using micro front ends. First, we've got our container application. The container app is going to own all of those global cross-cutting concerns. So things like the page header, things which are going to be there on every single page of the application. Things like navigation, login, anything like that, any of those cross-cutting concerns will be owned by the container. The other really important job that the container app has is figuring out which micro front-end should be being displayed right now, and then to tell it to render itself into that slot on the page. You might also hear this called a wrapper or a parent app. It all means the same thing. What we've done here is we've broken down our app into micro front-ends, essentially by looking at what our users see and saying, well, each one of those pages that a user can see, that will be a micro front-end. So we've got a browse micro front-end, which is for browsing through restaurants, searching, filtering, and picking the one that we want. There's going to be a micro front-end for actually ordering the food and showing the menu and the details for a particular restaurant. And there might be a profile micro front-end as well for showing the user profile. So this works really well. We've got nice, good domain encapsulation. We've got kind of a bounded context around not only our application, but also our teams. The first question is probably going to be, how do we actually do this? How do we assemble the page? How do we put those things together? There are lots of different options. I'm going to go through a few of them. The first one is a bit of a weird one because it's micro front-ends implemented purely on the server. So here's an HTML file. This is probably our index.html. It's got all of those common global page elements like the title and the heading, so it says the name of the app on there. And then it's got, it looks like a comment, but it's actually an Nginx server-side include. So what we're saying there is include into this page an HTML fragment and load that fragment from the file page.html, where page is actually a variable. So this is some dynamic content where we can include the relevant micro front-end into the page. The Nginx config would look something like this. We would say, let's always render index.html. We turn server-side includes on. And then we just have a simple mapping that says, depending on the location that's being requested by the user, we set the page variable to the right file name, so whether it's browse.html or order.html. And then when the index.html is rendered, the page will be constructed and the users will see what they should see. This might not seem very exciting, and you might be thinking, I thought I was coming to a front-end talk while you're talking about server-side includes, but the point of this example is to show that micro front-ends is not about kind of wacky JavaScript single-page application stuff. Yes, you can do it that way, but the whole point of it really is to think about how you can divide up your application into parts that can be worked on independently from each other. So we're simplifying our code bases, we're drawing those clean boundaries, and trying to make our teams as autonomous as they can be. And there are a whole bunch of different ways that we can chase those benefits, and this is just one of them. Another way that you can do it would be build time integration. So here we're seeing a package JSON for the container app, and this is describing how our application is going to be assembled. So the container app for FeedMe, it has some dependencies, and it pulls in the restaurants app, the ordering app, and the user profile app, and it's pulling them in basically as node modules. So you can imagine that each one of those three micro front-ends, rather than being deployed directly to production, they've actually been published as a library to probably to an NPM registry or something like that. This is tempting, and it kind of seems like it would make sense, but I usually wouldn't recommend this approach. And the reason is that it couples the release cycles of all of our applications. So if we do it that way, if we want to make a change to any of our micro front-ends, the only way we can actually put that into production is to go and make a change to the container application as well, even if it's just a version number bump. And then if we want to actually release that change, we can't just release our own micro front-end, we have to release the entire container, which means releasing every single other micro front-end as well. So you can imagine scenarios where I'm ready to release a new version of my application, but somebody else has accidentally integrated a bug into the container, and now I can't go live because I'm blocked by someone else saying, no, you can't release the app right now, it's not ready. Also, we should spare a thought for the team who's having to maintain that package JSON that we're currently looking at. I've seen this happen before where this approach was being used, and the team maintaining the container application, they basically became a glorified release management team. They spent all of their time fielding requests from other developers. Hey, can you please bump this version number for me? Hey, can you please integrate my changes? And they didn't have a whole lot of fun. So we're trying to avoid this lockstep release process and really aim for independent deployability. So instead of build time integration, you're usually better off doing runtime integration. So here's one way you can do runtime integration using JavaScript. So we're back to an HTML file here, and on the HTML file we've defined, again, those global top-level concerns. So we've got the title, we've got the header of the page. And then we drop 3 bundle.js files on there, and you can see they're all coming from different domains. So there's one JavaScript bundle for the browse, and then one for each of the other 2 micro frontends. Now those JavaScript files, when they load on the page, they don't really execute anything, they don't run. All they do is expose a global function, which is their entry point. The container app then defines, it's just a div, which is basically the mount point where any of those micro frontends is going to render themselves. Then it's just a matter of the container to, the container app will define the mapping for the micro frontends. So each one of those routes, we're looking at what is the client-side route. So if it's / then we're going to be calling the render browse restaurants global function. And if it's the other 2 routes, then we know which function we need to call. And those window functions, those were put there by those 3 bundles at the top of the page. Then it's just a matter of looking at what's the current window location. We can look that up into our map of micro frontends. That gives us a function. We can call that function, and we pass in the ID of the div where it should render itself. So when we put this all together, what happens is we've got our micro frontends defined. They're all there sitting on the page, ready to go, but not running yet. The container looks at whatever the current URL is and finds that micro frontend and tells it, OK, you render yourself right here into this div. In my experience, this is a much better way of doing your integration rather than build time integration, because we've made our applications a lot less coupled to each other, especially in terms of release. We can see that those different micro frontends, they're actually all deployed to different subdomains, so those are probably running on different servers, and we can push new code all the way into production without touching any other application. There are lots of different variations on this. Of course, you can optimize your downloads. You don't need to download all of those bundles immediately as soon as the page loads. You could download those dynamically depending on where the user currently is. You can do something similar to this using web components. Rather than having each micro frontend define a global function as its entry point, it could define a web component with a custom element type. And then the mapping there, instead of being from routes to functions, it would be from routes to custom element types. And then instead of calling a function, you would instantiate an instance of that custom element type and let it render itself. Another variation would be using iframes. Iframes have their own advantages and disadvantages, which I'm not going to go into, but you can do something similar to this using a mapping of routes to iframe sources and attach the relevant iframe source on the page. I don't have time to go into all these variations, but if you stick around to the end of the talk, I'm going to have some links that you can do some further reading on this. So moving on from integration, let's look at some of the other cross-cutting concerns that we have to address. Authentication. I'm not going to spend too long in this because, to be honest, it's not that different from how you would usually do auth in a monolithic front-end application. Auth is one of those, again, a global cross-cutting concern, so it's probably the container application's job to figure this out. So that the container app will be able to tell whether the user is logged in already and whether they're looking at something that they should be logged in to see. If they are, it can show them the login form, the user types in their information, the credentials get sent to the server probably sends us back some sort of token or cookie which we can use to know that the user is logged in. The container app would then own that cookie or that token, so it knows where to store it, what to do with it. And when it's invoking those micro frontends, it can pass that token into the micro frontend as just some extra context information. And then the micro frontend can use that token with any requests that it needs to make to the server. So speaking of communication with the backend, let's look at the BFF pattern. So I've stolen this diagram from Sam Newman's website. I did ask him. So BFFs, it stands for a couple of things. It obviously stands for backends for frontends, which is what's written there. It also stands for best friends forever, which is kind of nice. So when Sam was describing this pattern, he was, I think, writing about it in the context of multiple platforms or multiple channels. So we've got perhaps a native mobile client, and we might have a desktop client, which could be a web application. And even if they're kind of the same product, being on different platforms, maybe they've got quite different needs in terms of the data that they need, the format that they want the data in, what sort of requests they're going to make to the server. So rather than trying to construct one single API gateway that can serve the needs of all of these different platforms, we can create a backend for each one of those front ends. There's probably common downstream services that they both talk to, but now we can design an API which works really nicely for the front end that we're working on. Then we can take it one step further, and if we're looking at that desktop web client, and each one of those colored boxes is a micro front end, perhaps each micro front end gets its own BFF as well. Now, you don't have to do it this way, but again, thinking back to the profit and loss report example that I worked on a few years ago, we owned our own front end, we had our own BFF, which was highly coupled to our front end, and when we were making changes, we could do our front end and our back end changes, and this enabled us to get features into production really quickly and easily, because it was pretty rare that we had to touch those downstream services. So most of the things that we needed to change were fully owned and inside the boundary of our team. Okay, so moving on to one of the hardest things to do well, and that's styling. So our styles, of course, we need it to look good, but we also need it to be consistent, and perhaps most importantly, we need our styles to be predictable. So this is one of the hardest things to get right with micro front-ends. As you might know, CSS is kind of inherently global, inheriting, cascading. Historically, it's really had no module system or variables or any sort of namespacing or encapsulation. Now, some of those features do exist today, but the browser support is not always what we want. None of these are new problems. You're probably aware of them already, but I think they do become more challenging in a micro front-ends architecture. So let's see an example. Say I'm working on the container application, and I've defined a button, and it's the primary button, and I'm going to style that primary button and say that it should be red. Someone else in a different team is working on the browse micro front-end, and they also have a button, and they have said that they think their button is the primary button, and they've styled it as blue. So the question is, which one of those styles takes precedence? Actually, that's not the question. It doesn't really matter, because one of them is going to win and one of them is going to lose, and someone's going to be really upset that their button isn't the right color. Again, this is not a new problem. We've been battling this kind of thing forever with front-end development, but with micro front-ends, it's much worse, because that container application and that browse micro front-end and potentially 2 or 3 other micro front-ends, they were all built by different teams working on different timescales, different schedules, and we really don't want them to have to do excessive coordination. So every time I'm writing a new bit of CSS, I don't want to have to go digging through all of the different code bases, talk to all the different teams in my company, and say, hey, have you defined a class with this name yet? We need to be able to work independently, and we need to be able to write whatever styling code we need and be confident that it's going to do what we think it does in production, and that I'm not going to screw up somebody else's code, and they're not going to screw up mine. Of course, there's lots of options for addressing this. One of them would be naming conventions, like BEM, for example. In my experience, things like those naming conventions like BEM, they require quite a bit of effort and discipline from developers, and I think a lazy developer is a good developer, so I think we need a tool to do some of the heavy lifting here for us. Okay, Sass is one option. In this example, what we've done is we've wrapped, if we're in the browse micro front-end, we've wrapped our button inside a div with a unique ID. And this is going to be where our entire micro front-end will sit inside of that div in a nice little kind of sort of namespace. Then we write some Sass, and we put our selector nested inside an ID selector, and that will compile down to something like this. So now, rather than styling all of the primary buttons on the page, I'm only styling the primary buttons which sit within my micro front-end's unique div. This works pretty well. This will make sure that we're only going to style our own primary buttons. We're not going to style any primary buttons that are outside of our own little namespace. And because of the specificity of the ID selector, it's unlikely that someone else is going to override our style, unless they're using important, in which case I can't help you. So Sass is okay. It does solve this problem reasonably well, but in my experience, Sass is pretty easy to abuse. A lot of its features like nesting and mix-ins, for example, you can kind of tangle yourself up in a mess really easily with Sass. Also, it has some gross native dependencies. Whenever I try to install it, I seem to get C++ seg faults, so I stay away from Sass these days. I think a better option is something like CSS modules. With CSS modules, we would just write CSS selectors the way that we would normally write them. And every selector that we write is going to be namespaced automatically for us. So we write plain old classes, and they get pre-processed into something like this. So the name of our micro front-end, in this case browse, has just been tacked on the front of our class name. And then we do something a little bit weird. When we write our JavaScript, we can actually import our style sheet into our JavaScript module. And what we get is an object. If we console log styles.primarybutton, what we get is the namespaced class name. So we look it up using the original class name that we wrote, and what we get is the namespaced class name. Now that we know the actual real class name that's been namespaced, we can apply it to whatever element we need. So in vanilla.js, we could write a function called makeButtonPrimary, where we take in a button, and we just add to its class list the namespaced class name. Now, this works okay with vanilla JS, but where it works really well is if you happen to be defining your markup in JavaScript, like say with React. If we're using React, we could define a primary button component, and then the class name we apply using JavaScript. Now, once we've started going down this path of applying our styles from JavaScript, we can actually take this one step further and define our styling in JavaScript as well. So I'm going to continue with the React example. If we're defining our primary button, if we're doing all of our styling, applying it all from inside the component anyway, we may as well define it right there in the component and just use an inline style. The key advantage here is that we've stopped trying to use selectors and classes as the element of style reuse, and instead we're using components as the element of style reuse. And components are a much more powerful abstraction than classes and selectors. We can nicely encapsulate all of the semantics, the behavior, and the visuals into one place, and it works pretty well. There's a lot of things that you can't do with inline styles, like pseudo-selectors, for example. So there are whole libraries that have been written specifically to kind of address this problem, like styled components, for example. We can say that a primary button is just a styled button with the color blue. Now, this is starting to become a talk about React and styled components, which is not what the talk is about. It doesn't really matter which tool you choose. If you hate CSS and JS, you think it's a terrible idea, fine, I don't care. Pick whatever way you want to define your styles, but just think about how you're going to make sure that the styles that I write in one team don't go across the boundaries and affect elements that were written by somebody else in a different team. We need our developers to be independent and writing their styles without thinking about what's going on outside of their little world. So I have started mentioning React and some other libraries in the last slide. I think it's important to call out that React does not have a monopoly on micro frontends. It's probably what I've used the most in this kind of architecture and what I've seen the most from other people as well. But there's nothing stopping you from dropping whatever kind of library or framework you want onto the page if you're doing micro frontends. As long as your framework can be made to sit in one nice little spot on the page and behave itself, and it doesn't have excessive kind of global stuff going on where they're all going to interfere with each other, it can work. I would say that a library that has a strong component model probably works best for this kind of architecture, especially when it comes to defining component libraries, which I'll talk about in a minute. By the way, actually one benefit of micro frontends is that you can have a little bit more diversity and a little bit more flexibility in your tech stack. So going back to the P&L example, Essentials was a Backbone JS application, the kind of core of it, and we wrote our new application in React. So you can kind of mix and match. I probably wouldn't want to collect all of the frameworks and libraries on the page at once, but if you really want to do that, you can. So shared component libraries. This generally, I think, is a good idea. You can pull out components into a library so that every micro frontend doesn't have to redefine the same stuff over and over again. I think probably being able to save effort and deduplicate code is probably the least exciting part of having a shared component library. What's more exciting here is it gives you a lot more confidence that you've got consistent look and feel. If everybody's using the same definition of a button, then that button should look the same everywhere. And also, this can become a living style guide. So rather than trying to document our brand and document our styles, we can actually just code our brand and code our styles, and you know that it's always going to be up to date and correct. Also, even better than that, is this becomes a really good collaboration point for your developers and your designers. I often see devs and designers not talking to each other as much as they should be. By having something like this becomes a point where they can actually gather and work together and build this stuff together. So your shared UI component library, it's not just limited to primitives like buttons and labels. Those are probably the most obvious candidates. You can also construct more complicated things like layout components, or you could have something really intelligent like a auto-searching, suggesting drop-down box or something like that. I would say if you're going to have complex things in there, that's fine. You can have rendering logic and UI logic in there, but don't put business logic in there. So make sure it's a search box and not a restaurant search box or a customer search box. As soon as you start putting domain concepts or business logic into your shared library, it becomes very difficult to change that over time, because everyone who's consuming that library is going to be dependent on that business logic staying the same way that it is. So UI logic is okay, no business logic. The other thing I would say is don't try to build too much of this too early. It can be really tempting to think, before we start this project, let's sit down and create the whole complete style guide with all of the components, all of the elements we're ever going to need. My experience is that that's way harder than you think it's going to be, and I've personally done it before, and as soon as you actually try to consume that from a real application, you find out that all of the APIs that you designed for using your components don't actually fit with the way people want to use your components. So let people go out and write 5 different button implementations in 5 different micro front-ends. Once you find what the common bits are, you can extract those out, harvest those out from your applications into a library, rather than trying to write them into a library up front and then push it out to the applications. Let's talk about testing. So again, I'm not going to spend too much time on testing, and the reason is that it's not that different from how you would do it in a monolithic architecture. So each one of our micro front-ends is just a regular self-contained application that can be run independently. So it should have its own comprehensive automated test suite. So whatever you think is a good testing strategy for front-end apps, just do that once for each micro front-end that you have. The obvious question would be, well, what about integration testing that all of my micro front-ends actually cooperate on the page together? Yes, you should probably test that. You can do some sort of functional or end-to-end testing, but make sure you're focusing on just the actual integration points. Don't rewrite all of your business logic tests in functional tests, because I'm sure many of us have had experience maintaining those huge functional test suites. They take ages and they just fall over all the time, and they're a real pain. So using our food delivery example, you might have a functional test which just loads up the application at /. It would expect to see a list of restaurants. It might just click on the first one, whatever the first one is, and then expect to see a menu on the page, and that it can see a submit button to click to submit the order. And that's all you would write. There would be very few actual assertions there, just that the page roughly looks like the right page. That's enough to give us really good confidence that the container is working, the container can figure out which micro front end to render, the micro front end is rendering on the page, and that we can click a link to travel from one micro front end to another. And that's really all of the actual integration code that we have. All of the business logic around adding up menus, searching and filtering, do that in unit tests within the actual micro front end test suite. Okay, cross-component communication. So this whole integration thing and applications integrating with each other. This is hard to do well, so as a rule, just don't do it. If you can avoid your micro front ends talking to each other and integrating with each other, that's the best place to be. The reason is the whole point of this architecture is to try to split things apart and not have them highly coupled to each other and knowing about each other. So when I'm on this page over here, I shouldn't be knowing anything about some other page within the application. As soon as you start adding lots of communication and trying to sync state backwards and forwards between multiple pages, you're reintroducing all of that coupling, and it becomes much more difficult to change things. So don't try to share state across different applications, and don't try to send lots of messages between them. You probably do need some type of integration though, or some sort of communication going from one micro front end to another. The point is just that you need to think really hard about what that integration is, be really conscious that you are reintroducing a level of coupling between your applications. Be really explicit about what that contract is, because you are defining a contract between independent applications. So be explicit about that contract, document it, and make sure that people actually stick to it. You can probably explore contract testing as well as a way to actually verify that that contract is being stuck to. If you do find that you've got 2 micro front ends that have a lot of dependencies between each other and they're really chatty and you're always trying to define messages for them to send backwards and forwards, it's possible you've got your boundaries wrong, and maybe you need to actually just merge those 2 back into a single application again. So I'm going to cover a couple of frequently asked questions that always come up. The first one is, well, how big should my micro front ends be? What does micro mean? It really doesn't matter. They can be as big or small as you like. Just remember the actual benefits that we're chasing here. So we're trying to avoid those monolith pitfalls. We're trying to make things easy to maintain, easy to understand, easy to rewrite something if we have to. So make things small enough that your code stays simple and decoupled. But make things big enough, make your micro front ends big enough that they actually encapsulate a real kind of business purpose or a real set of functionality. If you're struggling to find a name for a micro front end, or if you can't explain the purpose of a micro front end to a non-technical person, it's possible you've made it too small or too abstract. The other thing that always comes up is, what about download sizes? So if you've got 5 different micro front ends being downloaded onto the page and they all depend on React, are we inflicting that on our users and forcing our users to download React 5 times? Sometimes, yes, that can happen. The thing to remember here is that a lot of single-page applications, probably most of the ones that I see, do one single download of the entire app. So as soon as you land on any page of the app, it downloads all of the code that's necessary to run the entire application, all of the different pages. With micro frontends, we've actually got a form of code splitting, which means when I load one page within the app, I'm only loading the code for that single page and none of the code for the other pages within the application. So this can actually make your initial page loads faster because you're not downloading everything. Then when I click through to other pages, again, I'm only downloading those pages one by one, but yes, there might be some duplication there. If we've got common dependencies across the different applications, I might be downloading something that I already downloaded on the last page load. You can try to get a bit clever here. With tools like Webpack, you can split out dependencies from your bundles. So you might say, if I know everybody depends upon React, maybe React isn't included in all of my micro front-end compiled JavaScript bundles. And instead, React is just there as a global dependency on the page. And all of the micro frontends will expect that to be there when they render themselves. You can do that, and yes, that might make it so you can deduplicate some of the dependencies that our users are downloading. But again, it comes back to coupling. Now we've reintroduced a point where everybody expects that thing to be there. And what if it's not the same version that everyone was expecting? What happens when we need to do a breaking change to a new major version of that dependency? Everyone's going to have to do a coordinated upgrade and then a lockstep release, so that's going to be really painful. So you can try to get clever, just be aware of the trade-offs that you've got there. There's really no easy answer to this problem. You really just have to do your own measurements. It's always easy to talk about these things in terms of hypotheticals. You have to try a few different things, do some measurements in production or something like production and see what kind of impact it actually has. So that's really all of my content. I did promise a couple of links at the end. So the big reveal here is that the FeedMe application is not a hypothetical app. It does exist. So if you go to demo.microfrontends.com, you will see it there. You can't actually order any food, so don't try to order dinner because you're going to go hungry. But you can go on there, you can search for a restaurant, you can click onto it, you can see what's there. All of the source code is on GitHub, so you can go to github.com/microfrontendsdemo. You'll see all of the source code for the micro frontends, the source code for the container, and there's some static content and some infrastructure on there as well, so you can see it all for yourself and you can have a play around with it. Please don't be too brutal on my code, I'm sure it's not perfect. The other thing is, I've been writing for a while a long-form article on micro frontends. If you recognize the styling there, this article will be appearing on martinfowler.com. I'm hoping in the next couple of weeks. I'm putting the finishing touches on this article, gathering feedback from a lot of people. So if you want more information, if you want to do a bit more in-depth reading, this article will go into way more detail than you'd ever expect on micro frontends, both as a concept, and it also explains all of the example code in the FeedMe demo application. So it will explain all of that code, what it does, and why it's done the way it's been done. So it's not up yet, but it will be very soon. So you can follow me on Twitter, or you can follow Martin on Twitter, and hopefully in the next couple of weeks the link will be coming out and you can have a read of that article, and I'd love to hear any feedback from anyone who reads it. So that's all the content that I have today. I hope that's been interesting and useful, and I hope some of you will go away and have a think about implementing micro frontends on your own applications. Thanks.